Hi, today we're going to go over some advanced factoring. That's factoring without using any calculators or the quadratic formula or any other tricks. Your teacher just says, hey, I'm going to give you some quadratics and I expect you to factor them manually. I'm going to give you some tricks to solve pretty annoying quadratics that show up an awful lot. And of course, the worst quadratics are those that have an extra coefficient hanging out in front of the x squared, right? Something like, ax squared plus bx plus c, where this a could be 32 or 64 or 48. And it creates a huge headache because when we have to, find our factor solution, we don't just have x plus a times x plus b, right? Because if we did that, we'd be left with x times x or x squared. Well, that doesn't work because, we have a out in front that we also need to have in our factored expression. And so we're going to resort to some special tricks to really get past this. And the easiest trick that I've found has been to factor by grouping. What is grouping? Well, grouping is when we find solutions that work and we group them together with parentheses. To show you what I'm talking about, we're going to start with a sample quadratic factor. Let's say 2x squared plus 5x plus 2. Now here, what I'm going to do is I'm going to multiply this coefficient by this term, right? So I have 4, right? I'm going to find the factors of 4 and find ones in particular that add up to 5, this middle term here, right? So I have 2 and 2, they don't add to 5, but I have 1 and 4. If I add them together, I did get 5. So I'm going to rewrite this 5x as 1x plus 4x, or x plus 4x. And I noticed something interesting. If I were to factor out, let's say, an x from here and a 2 from here, I'm going to be left with two things in parentheses that are the same. This is the same as this. So I'm going to go ahead and I'm going to factor this out of the entire equation. So I'm going to have 2x plus 1 times x plus 2. And if you look at it, we realize that we've actually factored this original big nasty expression. We've actually factored it into two smaller terms. And we've done this pretty successfully by grouping. Now you might say, okay, well, why did you put the the 1 and the 4 in those places? Are we going to get a different answer if we change the order? No, we're not. And to demonstrate that, I'm actually going to do just that. I'm going to switch the order. So we're going to have 2x squared plus 4x plus x plus 2. Right, so here, in this case, in this section, I can pull out a 2x, and I'll be left with x plus 2. And here, I can't pull out anything, but I am going to still keep it in parentheses, but I'm going to write 1. And you'll agree, if we were to take 1 and we were to multiply it by x and 2, we would still have x plus 2. And once again, we can pull out an x plus 2 from this entire equation and have x plus 2 times 2x right here plus 1 right here. And thus we've fully factored the expression, and we did indeed get the exact same answer. So the order doesn't matter. Let's try this out with another expression to get more comfortable factoring quadratics in this way. And this grouping strategy can be tremendously helpful in a wide variety of situations and problems, especially ones with an extra term attached to the x squared. So let's say we have something like 3x squared plus 8x plus 4. I'm going to multiply my coefficient next to that x squared with my non-x or constant term or integer or constant term. So multiply these two together and I get 12. I'm looking for factors of 12 that add up to 8. So 1 and 12, they don't work, they add up to 13. 3 and 4 don't work, they add up to 7. But 6 and 2 do work, they add up to 8. So I'm going to split up this 8x into 6x plus 2x. As we established before, the order in which I write, 6x over 2x, example, 2x plus 6 or 6x plus 2, it doesn't matter. I'm just going to write it one way, but you can feel free to use the other way. So we'll have 3x squared plus 6x plus 2x plus 4. I get out of parentheses. I'm going to look for things to factor out. Now I see from here, both of these terms have a 3 and an x in them, so I'm going to pull that out. And both of these have a 2 in them, so I'm going to pull that out. And I notice, once again, that I'm left with two terms that are the same. So I can pull out of this entire expression an x plus 2. I'm going to be left with the original 3x plus 2. And I have just factored that expression completely. And if you say, okay, I think I get the hang of this, but how can I use this on any problem? Well, the general form of this would be, okay, you have a quadratic ax squared plus bx plus c. Your first step is going to be, okay, find a times c, right? List out its factors until you get one that adds up to b, right? I'm going to call these factors x and y, and then you're going to write ax squared plus x. Oh, let me do it. Let's go c and d. So ax plus cx plus dx. Oh, d and e then. I'm so silly. D and e. So ax squared plus dx plus ex plus c. I'm going to break them apart, find things to factor out. We're going to get some sort of expression in parentheses that's the same with both terms. We're going to factor that out, and then we're going to be left with two terms that we can work with, and we'll have our completely factored quadratic. That is how you use the grouping strategy. I hope you found it helpful, and I hope you have a great day.